Okay, so the 2025 mock from DEB, paper 2, question 8 is a question about a ski lift. So it says, the diagram below shows the outline of a ski lift system from point A at the bottom of the mountain to point C at the top of the mountain, not to scale. The system comprises of 2 ski lifts from point A to an intermediate point B, and then from there to point C. The altitude, heights above sea level, of the points A and C are 650 metres and 2,727 metres respectively. The following measurements were also recorded on site. Okay, so I have loads of measurements here. I just want to make sure that I can see it all in my diagram. So from A to B, yeah, that's there, 1,500 metres. From B to C, 1,725 metres. The angle from B to A to D is 33. From A to D to B is 90 degrees, and then from A to E to C is also 90 degrees. Okay, so they have it all filled in there. Okay, so work out H1, the elevation gain of the first ski lift between points A and B. Okay, so in this triangle, okay, let's just do a little sketch of what that triangle is looking like. Okay, so it's a right angle triangle. Doesn't have to be 90 degrees in my sketch, but I just want it to be 90 degrees in mine so that you can see. Okay, so I have 90 degrees here. I have 33 degrees here. So in a right angle triangle, I'm always looking at Pythagoras or SOHCAHTOA. Okay, as soon as they give me another angle, I'm expecting it to be SOHCAHTOA, to be honest. Okay, then they give me 1,500 meters, okay, or 1,500 meters. And then they are asking, what is this? Okay, what is that there? Now, if I'm choosing between SOHCAHTOA and Pythagoras uses the 3 sides of my triangle, including the unknown. Okay, SOHCAHTOA, including my unknown, uses 2 sides and an angle and my right angle. So I'm going to be using SOHCAHTOA. Okay, so I'm going to write down the word SOHCAHTOA. Okay, and now I need to figure out, well, what part of SOHCAHTOA am I going to use? So what sides am I working with here? Well, I'm working with my hypotenuse, because I have the side opposite my right angle, that's my hypotenuse. And I'm working with the side opposite my angle, which is called the opposite side. Okay, so I am looking at SOHCAHTOA, I'm looking at, okay, well, from SOHCAHTOA, which part of it uses O and H? It's this SAW part. Okay, so I'm going to be using this SAW part of SOHCAHTOA. So write out the equation there for what SOHCAHTOA's equation is for SAW. Okay, so S, remember, stands for sine, so it's the sine of the angle is equal to the middle letter over the last letter, so the opposite side over the hypotenuse. Okay, so let's fill this in with what we know. I know that my angle is 33 degrees. Okay, make sure your calculator is set to degrees. So there should be a little D up the top of your calculator screen. If there's not, then just change it. Okay. In ordinary level, we never use anything other than degrees, so it should be already set to degrees. But if not, go back and change it there. Okay, so this is what we have. I need to rearrange this to figure out what question mark is. Okay, so I could have filled in that question mark as height or as X or anything like that. Okay, I just left it as question mark because that's what I have it as in my diagram. Okay, so I need to rearrange this to get question mark on a side by itself, which means I need to get rid of the 1,500 that is dividing it. So how do I get rid of something if it's dividing? I multiply. Okay, that's the inverse operation of dividing. So that means I need to multiply the other side as well. Okay, that way these ones will cancel, and I'll have a question mark on a side by itself. Okay, and then what is 1,500 by sine 33? I'll type it into my calculator, okay? If you found what sine 33 was first in this step, if you typed into your calculator sine 33 and saw it was like 0.544639, okay, that's fine, but you cannot round it. So if you had found sine 33 and you write that down as 0.54, you're significantly changing your answer to from what it should be. Okay, so please, if you've decided to put this in your calculator, the sine 33, that's absolutely fine, but you need to write down loads of decimal places, okay? At least 7 decimal places for if you get this answer out, okay? Because when I multiply it by 1,500, it's any small errors in the number I've written down are going to be dramatically increased. So, 1,500 by sine 33, okay, and I'm going to get 816.95855. Okay, and it says, so I think I've finished my question, and then I go back and reread it, and it says, give your answer correct to the nearest metre. Okay, so I'm going to be giving my answer as 817. And then my unit is metres. Okay. Next question says, work out the altitude, so the height above sea level of point B. Give your answer in metres. So, point B here, grand, lovely. We've just figured out that H is 817. Okay, so that's 817 metres. And they want to know, well, what is B's height above sea level? Okay, so it's literally just 817 plus 650 metres. It's literally just them two added together. Okay, so 650 metres plus 817 metres. So 1,467 metres. Hence, work out H2, the elevation gain of the second lift between points B and C. Give your answer in metres. Okay, so we now know that that total is 1467. They want me to use that, okay, because they've said hence. So let me just go back and see. So 1467 is the height up to B. Okay, so here is 1467 metres. Okay, and they want, okay, well, what is H2? What is this height here? Okay, now we know that those two together are going to add up to 2727. Okay, so a nice question there again. Okay, it's just what needs to be added on. So I'm going to literally just say 2727. Take away this height that I already have up to B. So up till 1467. So that I get 1260 metres. Okay, so here, this height here must be 1260 metres. So that they both add up to the 2727. Okay, then, sorry, no, this is just. Okay, so then it says, find A, the angle of elevation of point C at the top of the mountain, okay, from point B. Give your answer correct to the nearest degree, okay? So they want us to find alpha, A, an angle of elevation. So in your diagram, they were very nice to you because you don't actually have to read any of the rest of the question once you see it says find A, alpha, that's shown in your diagram, okay, other than the fact that it says correct to the nearest degree. So in your diagram, my iPad's just being a bit slow here. In your diagram, there's alpha, okay? There we go. There is alpha, okay? And it's a right angle triangle and I have two sides, okay? So it's a right angle triangle, including my unknown. I have two sides and an angle. So again, I am going to use SOHCAHTOA, okay? Now, I'm going to draw out a little sketch of my triangle down here. Again, so that I can really clearly from SOHCAHTOA see the information that I need. So my right angle triangle is here. This is the angle that I'm working with. They gave me that this length here was 1725 meters. And I just figured out that this height here was 1260 meters. Okay, so I need to find A, so I am using SOHCAHTOA again. I'm going to write down SOHCAHTOA and then I'm going to figure out, well, what part of SOHCAHTOA am I going to be using? So there is my angle. So I have the side opposite, so I'm going to be working with O, and I have the side opposite the right angle, which is the hypotenuse. So again, I'm actually working with sine, okay, because I'm using my opposite and my hypotenuse. Okay, so again, I'm going to write out my formula with nothing filled in. And then I'm going to write out my formula with everything that I know filled in. So I don't know my angle, I can write it as that A symbol, or I can just leave it as theta. Okay, and that is equal to the opposite side. So 1260 over the hypotenuse 1725. Okay, now I don't want just the sine of the angle. Okay, I want the angle by itself. So to get rid of sine, what do? Well, I'm going to use the inverse sine for the other side. Okay, so to get that angle on a side by itself, the alpha on a side by itself, I'm going to do the inverse sine, sine minus 1 of the other side. So that's 1260 over 1725. Okay, and I'm going to get 46.922855. Okay, and then it says to the nearest degree, so I'm going to get 47 degrees. Okay, part B, a new ski lift. So, a new ski lift from point A to point C is proposed as shown in the diagram. Okay, so no intermediate position, and it wants us to show that the angle from A to B to C is 166 degrees. Okay, so I'm going to just quickly fill in what I know from up here. Okay, so I figured out, do I have the length of B to C? Yeah, it's 1725. Okay, so I'm going to fill that in. So, no, hold on. Sorry, it's frozen again. There we go. Okay, so I'm going to fill in everything that I know. So I have some measurements here. Okay, alpha is here. I've just figured that out. So my alpha measurement was 47 degrees. Okay, this here is a right angle, so that is 90 degrees. This here was a right angle triangle, so 90, 33, which means that angle there, okay, is 180 minus 90 minus 33, so 57 degrees. Okay, and we need to figure out that one. So, I am going to write this out as an equation. Okay, so my angles from So the size of my angle from A to B to D plus the size of my angle from D to B to unknown here. So let's see, A, B, C, D, E, F. So we'll just call that point G. Plus the size of my angle from surely they had that. No, it's not called anything. So from G, so C to B to G, plus the size of my angle from A to B to C is all equal to 360 degrees. Okay, so of these, what do I know? So from A to B to D, it's 57. Okay, so that's 57 degrees. Plus from D to B to G is 90 degrees. Plus C to B to G is 47 degrees. Plus, and then this is the unknown I'm trying to find. Okay, remember when it says show, you're not actually filling in and saying, oh, look, it works. You're pretending you don't have that answer and you're trying to find it. So I'm trying to come up with the idea that that angle is 166 degrees. Okay, so what I'm going to do is I'm going to spot there that I can take all of these away. So 57, 90 and 47. I'm going to take all of them away. Well, I can add them all together and then take them all away from the 360 to get the angle ABC on a side by itself. Okay, so if I add all them together, I get 194. Okay, so 194 degrees plus that angle that I'm looking for, ABC, is 360 degrees. Okay, so I'm going to get rid of the 194 degrees to get the angle ABC on a side by itself. And then what we're going to get is that the angle by itself is 166 degrees. Okay, then it says consider the triangle ABC. Okay, so this triangle here, nope. Yeah, lovely. This triangle here. Okay, even if I couldn't do part one, they told me what the angle was, so I can actually say that that angle there is 166 degrees. Okay, use the cosine rule to work out the length of AC. So what other lengths do I have? So this is my triangle. I have A, B, C. Okay, in the last part, they had filled in that this was 1500, and then from B to C was 1725. Okay, they want the length from A to C. So it is not a right angle triangle, so I'm ruling out Pythagoras or SOHCAHTOA, which means I'm using the cosine rule or the sine rule. Okay, remember, sine rule is 2 sides and 2 angles. The cosine rule is 3 sides and an angle, including my unknown. Okay, so this is 3 sides and an angle, including my unknown, so it is my cosine rule. So straight away, I'm writing down what is my cosine rule. Okay, it is that A squared is B squared plus C squared. So look at its similarities so far to the theorem of Pythagoras, which also uses 3 sides. Okay, but this one's different because the angle isn't 90 degrees. So it's followed on then by minus 2BC cos, because it's the cosine rule, and then a capital A. What does the capital mean? It means that it's an angle, okay? Likewise, the fact that it follows cos, we know it must be an angle. Okay, so A is my angle. So here, 166 must be my angle. Now, if that is my angle, what is the side opposite it? Or sorry, what is the side small a? Okay, the side small a has to be opposite the angle. So side small a is the side opposite that angle, and then after that, B and C don't matter, okay, which sides they are, as long as they are not the sides opposite the angle that I'm working with. Okay, so let's get my marks for filling this in fully correctly. Okay, so a squared, I don't know what a is, so I can leave it as a, or I can write like the length from a to c, or I could call that side x, or fill in a question mark. Okay, and then B, I am filling in 1,500. For C, I'm going to be filling in 1,725. Okay, so both of those are squared, just like they would be in the theorem of Pythagoras. And then I'm taking away 2 times B times C, so 1,500 times 1,725. Okay, and whatever my answer for all this is, it's also multiplied by the cosine of my angle, which we know is 166 degrees. Okay, so you can type this full thing into your calculator if you want. And that is going to give us whatever AC's length squared is. Okay, so 1,500 squared is 2250000. Okay, 1,725 squared is 2,975,625. Okay, so I can be doing all these out piece by piece, or I can just type it all into my calculator and get that it is 246,905. Point 383478. Okay, now that is clearly not what the side AC is equal to. It's way bigger than the other sides. Okay, so look at it and realise, oh yeah, that's AC squared, so I need to square root. Okay, so the length from A to C, when I square root that, is 3,201.078,784. Okay, now reread the question. It says give your answer correct to the nearest metre. So I'm going to round it to 0 decimal places, and I'm going to remember to write my units. They are metres. So 3201 there. Okay, now consider again the triangle ABC. Use the sine rule to find the angle from C to A to B. Okay, so I'm going to draw another sketch of my triangle. Okay, I just actually want it to be fully in the box. So again, I have an angle here of 166 degrees, okay, and they want the angle from C to A to B, so they want that angle there. Okay, I can call it alpha, I can call it theta. Okay, now when I am using the sine rule, the key thing is, and we can see this when we look at the sine rule. Okay, so my sine rule is sine A over small a equals sine B over small b. So when the letters are the same, it just means they're the opposite sides to each other. So I have 2 angles that I'm working with here. Okay, if I was to call them sides A and B, or sorry, the angles angles A and B, then the sides opposite those have to be the small caps of those letters. So this side here has to be small a, because it's opposite the angle large A. Okay, and this side here, because it's opposite the capital B, has to be side small b. Okay, so that is how I need to fill this in. That side there, the small a side, we can see up here is 1725. So small a is 1725. Okay, small b, we've just found it over here, it's 3201. Okay, so fill in your formula. So it's sine of my angle at A, which we've just have theta, okay, or you leave it as capital A. And then small a, so remember small letters show sides, capital letters show angles. And that is equal to sine of 166 over 3201. Okay, so yeah, that's everything. I can type this full right hand side into my calculator. Okay, this side I'm going to need to work on getting theta by itself. Okay, so whatever I get over here, I'm going to be multiplying by 1725 to get rid of that 1725 that's dividing. Okay, so I want to get rid of the 1725 that's dividing. So I am multiplying that side by 1725, which means I have to multiply this side by 1725. Okay, then these cancel and I'll be left with theta being sine 166 over sine theta 3201 by 1725. Okay, now I want not sine theta, I want theta by itself. So I have all this, I have to get the inverse sine of all that to get theta on a side by itself. Okay, so theta is the inverse sine minus 1 of. So I'm going to have sine 166 over 3201 times 1725. Okay, and now I can type all that into my calculator. And I'll get 7.49. Okay, it says correct one decimal place, so I'll write out a few more decimal places. 7.490989. Okay, and then to one decimal place, so it's 7.5. Okay, degrees. Okay, and then lastly, hence find H3, the elevation of the new ski lift above point B as it passes over that point. Okay, so let's draw out a sketch of this triangle again. Okay, so this is probably the most difficult part of this question. Okay, we have 7.5 degrees here. And we have that this is 1500. Okay, so I'm just trying to make it really clear to myself what I actually have. Okay, what they want here is what is the elevation over this point B? So how far up above that does this new lift go? Okay, so they want me to be looking at this distance here. Okay, now that is not, when I fill that in, it's not creating a right angle triangle. So I amn't going to be including Pythagoras or SOHCAHTOA here. Okay, what I do need to do is I need to try and figure out, well, what other information do I have? Okay, so in around this triangle here, what other information do I have? Okay, so go back up to where that triangle is. There we go. Actually, do you know what I'll do? There we go. Okay, so where this triangle was, did I have any other information? No. I'll scan through the other pages. Information shown, no. Here, information, yeah, okay, there was a 57-degree angle below. Okay, so in this, I'll just pop in there that was a 57-degree angle below that. Okay, so, oops. So if that line was to continue downwards, then this part here is 57 degrees. Okay, so what type of triangle have I created? I don't have a right angle triangle. What I do have is a triangle that looks more like this. Uh, 7.5 degrees. Okay, I'm looking for this side. I'm going to call it X. Okay, I have this 1500. And do I have anything else? Yeah, well, I actually have this angle if I look at the fact that that's 180 degrees. Okay, if I look at the fact that that's 180 degrees there, then what is that angle there? It's 180 minus 57, so it's 123 degrees. Okay, so 123 degrees. So now I am looking at a triangle where I have two sides that I'm going to be working with and two angles, okay? We did just discuss the fact that in the sine rule, it has to be the two sides opposite the two angles, okay? And that's not the two sides that I'm working with. So what I'm going to do is I'm just going to get this angle here, okay? That way I can pair up 1500 with the angle opposite it, and I can pair up X with the angle opposite it. Okay, so I'm just going to find my missing angle from up here, because I know that all the angles in a triangle add up to 180 degrees. So I can see what's missing, and it's going to be 49.5 degrees. Okay, and then I can use my sine rule. I have two pairs of angles and matching sides. So I'll write down my sine rule. Now, up here, the sine rule that I wrote down was sine A over side A equals sine B over side B. Okay, but I like when I have it sorted out in a way that my unknown is going to be on the top line. So you can do it like that, but it'll take a bit more rearranging. Okay, the nicer way of being able to fill this in is if I flip both sides. Okay, so that I get A over sine A equals B over sine B. That way when I fill it in, my unknown is going to be on the top line. It's just going to make it a little bit easier for me to rearrange. Okay, so one side and its matching angle, and then another side and its matching angle. Okay, so I already have some written in blue. Okay, so I'll call them A and side small a. And then I'll call the other ones B, so angle B, and side small b. Okay, so fill those in. So side small a was 1500 over sine of my angle capital A, which was 49.5, and that's equal to side small b, so X, I just can't write it at the moment, There we go. Okay, so that's equal to side small b. So x over sine capital B was 7.5. Okay, so now I need to get x on a side by itself. So I'm going to rearrange this. So how do I get rid of this sine 7.5 that's dividing? Well, I can just multiply across by sine 7.5. Okay, so multiply across by sine 7.5 there. And then I have to multiply this side as well by sine 7.5. Okay, on this side they'll cancel and I'll be left with x by itself. And on this side I can type it all into my calculator so that I get 257 meters. Okay. That's it done.